The following problem states boron has two naturally occurring isotopes, boron 10 and boron 11, which have masses of 10.0129 and 11.0093 AMUs. Given the average atomic mass of boron, determine the percent abundance of each isotope. So in this problem, they are giving us the average atomic mass of boron and the two isotopes and the masses associated to them for boron. However, they don't give us the percent abundance of each. And so that's what we're trying to find in this problem. So let's go ahead and set up the equation of what you would use for to solve for the average atomic mass. Well, you take each of your isotopes multiplied by the percent abundance, and you'd add them. And that would be equal to your average atomic mass. So in this case, 10.81. So we don't know x or y, but how are we going to solve for this? Well, we know x plus y must be equal to 100, or in this case, if you have the fraction, 1. So we can just set up a system of equations. We can solve for either of these two variables, replacing it so we can have only one variable in there. We can solve for that single variable. So I'm going to replace y, so I'm going to solve this equation for y. So y is equal to 1 minus x. And now all we do is we plug that into the following equation, and we can solve for x. So we have 10.0129 x plus 11.0093 times 1 minus x is equal to 10.81. All we have to do in this case is distribute out. So we're using the distributive property. And so we can further simplify and combine all like variables. So we have 10.0129x plus 11.0093 minus 11.0093x is equal to 10.81. Let's go ahead and combine our like variables and transfer, and also remove everything that doesn't have an x to the other side of the equation. So we're going to minus this to the other side of the equation. Then we're going to combine these two like terms. We end up getting negative 0.9964x is equal to negative 0.1993. Now we solve for x, so we divide each side by negative 0.9964. We get x is equal to 0.200. We can easily solve for y because we can go back into this equation and do 1 minus x, and so y is equal to 0.800. And so our percent abundances are for isotope of boron 10, this has an abundance of 20%. And for boron 11, this has a percent abundance of 80%. That's how you solve this problem. It is important to understand how we were able to set up these equations, because if we know x plus y has to be equal to either 100% or in the fraction form 1, we can easily rearrange the equation and solve for a single variable by using a system of equations. Thank you. Have a wonderful day.